Far beyond the warmth of the inner solar system, beyond the calm blue world of Earth, there drifts a planet so enormous, so alien, that it seems almost unreal. Saturn. From a distance, it looks beautiful. Golden clouds, elegant rings stretching hundreds of thousands of kilometers through space. But beauty can be deceptive, because Saturn is not a peaceful world. It is a realm of violent storms, crushing gravity, and winds faster than anything on Earth. A planet where lightning storms rage for months, where temperatures plunge to deadly extremes, where its immense gravity controls more than 80 moons and a vast ring system made of ice and rock. Deep within its atmosphere, pressure rises to unimaginable levels. The clouds grow darker, the winds grow faster. And somewhere far below the visible surface, the planet hides an ocean of metallic hydrogen surrounding a mysterious core. Even its rings, one of the most beautiful sights in the solar system, are made of billions of frozen fragments orbiting at incredible speeds like cosmic blades. Saturn may look calm from afar, but up close, it is one of the most extreme environments in our solar system. A giant world of storms, darkness, and unimaginable forces. Before we journey deeper into the terrifying secrets of Saturn, subscribe to Stellar Depth as we continue exploring the most extraordinary and mysterious worlds in the universe. The giant in the darkness. Saturn drifts through the outer solar system like a silent giant. From Earth, it appears peaceful. A pale golden sphere wrapped in delicate rings, shining softly in the darkness beyond Mars and Jupiter. Through a small telescope, it almost looks unreal, like a tiny ornament hanging in space. The rings seem thin and elegant. The planet seems calm, but this calm appearance hides something far more extreme, because Saturn is not just another planet. It is a colossal world of storms, crushing gravity, and unimaginable atmospheric forces, a place where the familiar rules of planets begin to break apart. To understand why Saturn can be considered one of the most terrifying worlds in the solar system, we first need to understand its true scale. Saturn is enormous. Its diameter is about 120,000 kilometers, nearly 10 times wider than Earth. If Saturn were hollow, you could fit more than 760 Earths inside it. Even compared to the other giants of this solar system, Saturn stands out as one of the most massive and dominant bodies orbiting our sun. Only Jupiter is larger, but Saturn possesses a strange property that sets it apart from every other planet. Despite its massive size, Saturn is incredibly light for a planet of its scale. In fact, Saturn is so low in density that if you could somehow place it in a gigantic ocean large enough to hold a planet, Saturn would float. Of course, such an ocean does not exist. But the fact itself reveals something important about Saturn's structure. Saturn is not a solid world. It has no true surface. There are no mountains, no oceans, no continents, no place where a spacecraft or a human could stand. Instead, Saturn is made almost entirely of gas, mostly hydrogen, large amounts of helium, and traces of other elements mixed into its enormous atmosphere. This means that Saturn is not a planet in the familiar sense. It is more like a gigantic sphere of atmosphere, layered thousands of kilometers deep. And within that atmosphere, the conditions grow more extreme the deeper you go. At the visible top of Saturn's clouds, the temperature is already incredibly cold, around minus 180 degrees Celsius. This is colder than the coldest places on Earth. Sunlight is weak here. Saturn lies nearly 1.4 billion kilometers from the Sun, where sunlight is about 100 times dimmer than it is on Earth. The planet exists in a region where warmth is scarce and darkness dominates. Yet despite this distant cold environment, Saturn's atmosphere is far from quiet. Powerful winds tear across the planet at astonishing speeds. Some of Saturn's equatorial winds reach 1,800 kilometers per hour. That is faster than the speed of sound on Earth. Entire cloud systems are ripped apart and reshaped by these supersonic atmospheric currents. Vast storms form and stretch across regions larger than continents. These winds circle the planet in massive bands, similar to Jupiter, but often faster and more chaotic. And these are only the upper layers. If you could somehow descend deeper into Saturn's atmosphere, the environment would become increasingly violent. First, the clouds would thicken. The pale gold color would darken into deeper shades of yellow, orange, and brown. Storm systems would appear larger and more turbulent. Lightning flashes, thousands of times more powerful than those on Earth, would illuminate the clouds. Because Saturn produces some of the most powerful lightning storms in the solar system, these lightning bolts can be 10,000 times stronger than typical lightning on Earth. The energy released in a single discharge could power an entire city for days, but lightning is only the beginning. As you descend further, pressure begins to increase. At first it doubles, then triples, then multiplies into crushing levels far beyond anything humans could survive. The deeper you go, the heavier the atmosphere becomes. Hydrogen gas grows denser and denser until it behaves almost like a liquid. Eventually, pressure reaches millions of times the atmospheric pressure on Earth. And somewhere deep inside this unimaginable environment, something extraordinary happens. Hydrogen, the simplest and most common element in the universe, begins to transform. Under immense pressure, hydrogen atoms are forced so close together that their electrons begin to move freely. The gas changes states and becomes something called metallic hydrogen. Metallic hydrogen behaves like a liquid metal. It can conduct electricity. It can generate magnetic fields. And inside Saturn, this metallic hydrogen layer is enormous. It forms a deep ocean surrounding the planet's mysterious core. This strange metallic sea is believed to be responsible for Saturn's powerful magnetic field, a field that stretches far into space, interacting with the solar wind and creating vast auroras around the planet's poles. These auroras are enormous. While Earth's northern lights glow beautifully across our sky, Saturn's auroras can span areas larger than the entire planet Earth. But perhaps the most frightening thing about Saturn is not its storms, its pressure, or even its metallic hydrogen ocean. It is the fact that there is no clear boundary where the planet truly begins. If you attempted to descend towards Saturn, there would be no moment when you could say you had reached the surface. Instead, the atmosphere would simply grow thicker and thicker. The pressure would grow heavier. The winds would grow stronger. And eventually, the crushing weight of the planet would destroy anything that tried to go too deep. Saturn is not a world you could land on. It is a world that would slowly swallow you. Your spacecraft would descend through clouds of ammonia and water ice, then deeper through dense layers of hydrogen gas, then into regions where temperatures climb and pressure rises beyond survival. Long before reaching the inner layers, the spacecraft would be crushed, torn apart by forces too extreme for any known materials. In that sense, Saturn is not just a planet. It is more like a cosmic ocean of atmosphere with depths that stretch tens of thousands of kilometers into darkness. But Saturn's terror does not end with its interior, because surrounding the planet is one of the most famous and beautiful structures in the solar system, the rings. At first glance, Saturn's rings appear delicate and thin. From Earth, they look almost like a fragile halo floating around the planet. But this is an illusion. Saturn's ring system is enormous. The rings stretch over 280,000 kilometers across, nearly the distance between Earth and the Moon. Yet despite their enormous width, the rings are incredibly thin. In many places, they are only 10 meters thick, and they are not solid. They are made of billions of individual fragments. Some are as small as grains of sand. Others are as large as houses. These fragments are made mostly of water ice, mixed with rocky debris. Each piece orbits Saturn at incredible speed, tens of thousands of kilometers per hour. This means that if you were flying through Saturn's rings, the environment would be extremely dangerous. It would not look like a smooth disk. Instead, it would resemble a vast storm of frozen debris racing around the planet. Chunks of ice would pass each other at enormous speeds. Collisions would occur constantly. The rings are beautiful from afar, but inside them, it would feel like traveling through a field of cosmic bullets. Yet even this is not the most mysterious aspect of Saturn, because Saturn is not alone. Orbiting this giant world is an entire family of moons. More than 80 known moons circle Saturn. Some are tiny irregular rocks. Others are entire worlds. And among these moons are some of the most bizarre and fascinating places in the solar system. One moon hides a global ocean beneath a frozen crust. Another has lakes and seas of liquid methane. Another appears like a giant sponge of ice. These moons form a miniature solar system of their own. And Saturn sits at the center, controlling them all through its immense gravity. The planet's influence extends millions of kilometers into space. Everything in this region, rings, moons, dust, and ice, moves under Saturn's command. This is why Saturn can feel almost like a cosmic kingdom, a massive world surrounded by orbiting structures and smaller worlds. But beneath that elegance lies an environment that would be utterly hostile to life as we know it. Violent winds, crushing pressure, blinding lightning, a bottomless atmosphere, and a giant planet that could swallow entire worlds in its gravity. Saturn may be beautiful, but beauty in the universe often hides danger, and Saturn is a perfect example of that truth. From far away, it is one of the most breathtaking sights in the solar system. Up close, it is one of the most extreme and unforgiving environments imaginable, and we have only just begun to explore it. Because Saturn still holds many secrets, hidden within its storms, its rings, and the mysterious world that orbit around it. In the next part, we will explore something even more astonishing: the storms of Saturn. Because on this distant giant planet, storms do not behave the way they do on Earth. Some of them can last for years. Some grow larger than entire planets, and one of them forms a perfect geometric shape that has puzzled scientists for decades. A storm that looks like a giant hexagon, spinning endlessly at Saturn's North Pole. And that strange storm may reveal something deeper about the terrifying power hidden within this giant world. The storms of Saturn. If you could watch Saturn for long enough, you would notice something strange. The planet never truly rests. Its clouds are always moving. Massive bands of gas circle the globe at tremendous speeds, sliding past one another in wide belts that wrap around the planet like colossal rivers in the sky. From a distance, these bands appear smooth and orderly, but closer observation reveals a far more violent reality. Saturn's atmosphere is a world of storms, not the kind of storms we experience on Earth, storms that last for hours or days. On Saturn, storms can grow to unimaginable sizes. Some stretch across distances larger than our entire planet. Others erupt suddenly and spread across huge portions of the atmosphere before fading slowly over months. These storms are fueled by the incredible energy hidden inside the planet. Even though Saturn lies far from the sun, receiving only a fraction of the sunlight that reaches Earth, the planet actually radiates more energy than it receives. Deep within Saturn's interior, heat left over from its formation continues to rise toward the surface. This internal heat powers enormous atmospheric motions, driving wind that circle the planet at astonishing speeds. Near Saturn's equator, winds can reach 1,800 kilometers per hour. To understand how extreme this is, imagine the fastest hurricane ever recorded on Earth. Now imagine winds several times stronger, moving continuously across the planet, thousands of times larger than the storm itself. These winds never stop. They race around Saturn in vast atmospheric streams, separating the clouds into distinct bands of color: pale gold, cream, faint orange, and soft brown. Within these bands, storms constantly form and dissolve. Sometimes they remain small and local, but occasionally, Saturn produces something much larger, something truly extraordinary. Every few decades, Saturn experiences what scientists call a great white spot. These are gigantic storms that erupt suddenly in the planet's atmosphere. At first, they appear as bright white clouds rising rapidly through the upper layers of gas. Within days, they begin expanding outward in all directions, growing larger and more turbulent. Soon, the storm spreads across huge portions of the planet. The clouds swirl violently, forming enormous spiral systems that can be seen even from Earth through powerful telescopes. Lightning flashes constantly within these storms, illuminating the atmosphere with bursts of energy far more powerful than anything on our planet. Eventually, the storm can grow so large that it encircles the entire globe. Imagine a storm wrapping itself around an entire planet. That is what Saturn can produce. These global storms are so powerful that they can disrupt Saturn's atmosphere for years after they begin. Even when the visible clouds fade, the energy they release continues to ripple through the planet's atmosphere, altering wind patterns and cloud structures across thousands of kilometers. But even these enormous storms are not Saturn's most mysterious weather system. Because at Saturn's North Pole, something even stranger exists. Something that should not exist at all. A giant hexagon. Discovered in the early 1980s by NASA's Voyager spacecraft, this structure shocked scientists. Instead of the swirling circular storms normally seen on planets, Saturn's North Pole is dominated by a massive six-sided jet stream. The shape is perfectly geometric, a hexagon. Each side of this structure stretches roughly 14,000 kilometers, longer than the diameter of Earth itself. The entire hexagon rotates slowly around the pole, completing a full revolution approximately every 10 hours, about the same time it takes Saturn to rotate once on its axis. At first, scientists believed the shape might disappear after some time, but it did not. Decades later, the Cassini spacecraft arrived at Saturn and observed the hexagon again. It was still there. The storm had persisted for more than 30 years, and it continues to exist today. Inside the hexagon lies another enormous storm, a swirling vortex similar to a hurricane, but vastly larger. This polar storm spins endlessly within the geometric jet stream surrounding it, like a cyclone trapped inside a six-sided boundary. Why the storm forms a hexagon remains one of the great mysteries of planetary science. Laboratory experiments have shown that rotating fluids can sometimes form polygonal shapes under certain conditions. In Saturn's case, the hexagon is thought to be caused by a powerful jet stream moving at hundreds of kilometers per hour around the pole. But even with these experiments, the exact reason Saturn's storm maintains such a stable, geometric structure remains unclear. No other planet in the solar system has anything like it. Saturn's atmosphere hides yet another violent feature as well. It's lightning. Lightning on Saturn is vastly more powerful than lightning on Earth. When lightning strikes inside Saturn's storms, the bursts of energy can release thousands of times more power than a lightning bolt on our planet. These electrical storms produce radio signals so strong that they can be detected by spacecraft orbiting the planet from far above. The Cassini spacecraft recorded these signals for years, revealing enormous thunderstorm systems deep inside Saturn's clouds. Some of these storms lasted for months. Imagine thunder echoing through a storm system the size of a continent, except that continent floats within a planet made entirely of gas. But the violence of Saturn's atmosphere becomes even more terrifying when we imagine what it would be like to actually enter it. If a spacecraft descended toward the planet, it would first encounter the upper cloud layers. These clouds are made mostly of ammonia ice crystals. They form the pale bands visible from space and drift slowly through the high atmosphere. At first, the environment might seem calm, but the deeper you descend, the more dangerous the conditions become. Below the ammonia clouds lies another layer made of ammonium hydrosulfide, a strange chemical compound rarely found on Earth. These clouds are darker and thicker, forming murky regions where sunlight barely penetrates. Below them lies yet another cloud layer composed of water vapor. This is where the most violent storms occur. Deep within these water clouds, immense convection currents rise upward, similar to thunderstorm systems on Earth, but on a scale thousands of times larger. Lightning flashes illuminate towering columns of gas rising through the atmosphere. The deeper you go, the hotter it becomes. Temperatures begin to rise rapidly. The pressure grows heavier and heavier. Eventually, the atmosphere becomes so dense that it behaves almost like a liquid ocean of hydrogen gas. Winds still move through this strange fluid, but visibility would vanish completely. Darkness would surround you, broken only by occasional flashes of lightning far above. And all the while, Saturn's gravity would be pulling you deeper. Unlike Earth, where gravity remains fairly constant near the surface, Saturn's gravity gradually increases as you descend through the planet's atmosphere. The deeper you fall, the more powerful the pull becomes. But the most frightening part of Saturn's atmosphere is that there is no clear end. No surface, no solid ground waiting below. Instead, the atmosphere simply grows thicker and hotter, transitioning slowly into the dense interior layers of the planet. Somewhere far below the clouds, the hydrogen gas becomes liquid. Then, deeper still, the liquid hydrogen transforms into metallic hydrogen, a strange substance where electrons move freely like those in a metal. This metallic ocean surrounds Saturn's core and generates the enormous magnetic field that extends millions of kilometers into space. That magnetic field creates another dramatic phenomenon around the planet: radiation belts. These belts trap high-energy particles within Saturn's magnetic environment, forming invisible regions of radiation that would be extremely dangerous to spacecraft and completely lethal to humans. Saturn's magnetic field also interacts with the solar wind to produce enormous auroras at the poles. These glowing rings of light swirl through the upper atmosphere like curtains of green and purple fire, stretching across regions larger than Earth. Seen from space, the auroras are breathtaking. But they are also a reminder of the enormous electromagnetic forces surrounding the planet. Saturn's atmosphere, storms, lightning, winds, radiation, and magnetic fields combine to create one of the most hostile environments anywhere in the solar system. And yet, despite all this violence, Saturn remains strangely beautiful. The planet's pale golden clouds glow softly in sunlight. The rings shimmer like frozen waves suspended in space. The storms twist gracefully through the atmosphere like slow-moving paintings. Beauty and danger exist side by side on Saturn. But Saturn's terror does not come only from its atmosphere. Because orbiting this giant planet are some of the most mysterious worlds ever discovered. Moons that hide oceans beneath frozen shells. Moons where methane rains from the sky. Moons that may even contain the chemical ingredients necessary for life. These moons exist within Saturn's powerful gravitational system, shaped and influenced by the giant planet that commands their orbits. And among them lies one moon that may be the most extraordinary of all, a frozen world called Enceladus, where geysers erupt from cracks in the ice, blasting water from an underground ocean into space. In the next part, we will explore the strange and fascinating moons of Saturn. Because while Saturn itself may be terrifying, the worlds orbiting it may hold secrets even more surprising. The kingdom of moons, Saturn is not alone. Around this enormous planet moves an entire family of worlds, dozens upon dozens of moons drifting through the darkness, each locked into orbit by Saturn's immense gravity. These moons form a miniature planetary system of their own, a complex cosmic dance where ice, rock, and strange alien landscapes circle endlessly around the giant planet. More than 80 known moons orbit Saturn. Some are small, irregular chunks of ice only a few kilometers across. Others are enormous worlds, large enough to rival planets in their own right. Each of them exists under the constant gravitational influence of Saturn, shaped by its pull and locked into delicate orbital patterns that have lasted for billions of years. Among these moons, some are so strange that they seem almost impossible. They have landscapes that do not resemble anything found on Earth. And some of them may even hide environments where life could potentially exist. The largest of Saturn's moons is Titan. Titan is not just another moon, it is an entire world. With a diameter of more than 5,000 kilometers, Titan is larger than the planet Mercury. It is the second largest moon in the entire solar system, surpassed only by Jupiter's moon Ganymede. But Titan's most astonishing feature is not its size, it is its atmosphere. Titan is the only moon in the solar system with a thick atmosphere. In fact, Titan's atmosphere is denser than Earth's. If you stood on Titan's surface wearing a very warm and protective suit, you would experience atmospheric pressure similar to what we feel on Earth at sea level. But everything else about Titan would be completely alien. The sky would appear hazy and orange. The sunlight would be dim, filtered through layers of thick hydrocarbon clouds drifting high above the surface. The temperature would be brutally cold, around minus 180 degrees Celsius. But the most astonishing discovery on Titan is what exists on the surface: lakes, seas, and rivers. At first, this seems impossible. Titan is far too cold for liquid water. Under those freezing conditions, water becomes rock-hard ice. But Titan has something else flowing across its landscape: liquid methane. Methane and ethane, hydrocarbon gases on Earth, become liquids in Titan's freezing temperatures. They form vast lakes and seas scattered across the moon's surface. Some of these lakes are larger than the Great Lakes of North America. Rain falls from Titan's sky. But instead of water droplets, the rain consists of methane. Rivers carve channels across the icy landscape. Winds shape enormous fields of dark sand dunes made from organic particles that drift through the atmosphere. Titan has a complete weather system. Clouds form, rain falls, rivers flow, lakes evaporate, and the entire cycle repeats again and again. It is the only place in the solar system besides Earth where stable liquid exists on the surface of a world. But Titan is only one of Saturn's extraordinary moons. Another moon, much smaller but perhaps even more mysterious, orbits closer to Saturn. This moon is called Enceladus. At first glance, Enceladus seems unremarkable. It is only about 500 kilometers wide, a tiny world compared to Titan. But when the Cassini spacecraft arrived in Saturn's system and began studying this small moon, scientists discovered something astonishing. Enceladus was erupting. From long cracks near its south pole, enormous geysers of water vapor and ice particles were blasting into space. These geysers shoot material hundreds of kilometers above the moon's surface, forming towering plumes that escape into Saturn's orbit. The particles released from Enceladus even help supply material to Saturn's E-ring, one of the faint outer rings surrounding the planet. But the existence of these geysers raised a crucial question: where was the water coming from? The answer was extraordinary. Beneath Enceladus's frozen crust lies a global ocean. Hidden beneath kilometers of ice, liquid water exists in a vast underground sea, warmed by tidal forces created by Saturn's gravity. As the moon orbits the giant planet, Saturn's pull stretches and compresses Enceladus slightly, generating heat inside the moon's interior. This heat prevents the underground ocean from freezing completely. The result is a hidden ocean beneath the ice, a dark alien sea sealed away from the surface. Even more astonishing, when Cassini flew through the plumes erupting from Enceladus, it detected organic molecules within the water vapor. These molecules are considered essential building blocks for life. The plumes also contain tiny grains of silica, particles that form on Earth in environments where hot water interacts with rock, such as hydrothermal vents on the ocean floor. These discoveries suggest something remarkable. Enceladus may contain hydrothermal activity beneath its ocean. On Earth, hydrothermal vents deep in the ocean support entire ecosystems of life. Strange organisms thrive there without sunlight, using chemical energy from the vents instead. If similar environments exist beneath the icy crust of Enceladus, it is possible that life could exist there. A hidden ocean, protected beneath ice, warmed by geological energy. In many ways, Enceladus may be one of the most promising places in the solar system to search for extraterrestrial life. But Saturn's strange moons do not end there. Another moon, called Iapetus, looks unlike anything else in the solar system. One half of Iapetus is bright and icy, reflecting sunlight strongly. This other half is extremely dark, so dark that it absorbs almost all light that hits it. This dramatic contrast creates a world that appears half white and half black, like a cosmic yin-yang symbol floating in space. Scientists believe the dark material may come from dust drifting inward from Saturn's outer regions, slowly coating one hemisphere of the moon over millions of years. But even today, the exact details of how Iapetus developed this strange appearance remain uncertain. Another moon, Mimas, resembles the famous Death Star from science fiction. A gigantic impact crater dominates one side of the moon, so large that it nearly shattered the entire world when it formed. The crater's central peak rises like a mountain in the middle of a circular basin, hundreds of kilometers wide. Seeing Mimas in space is almost surreal. It looks as if a giant weapon carved a perfect crater into its surface. Then there is Hyperion. Hyperion is one of the most bizarre moons ever discovered. Instead of being spherical like most large moons, Hyperion looks like a giant sponge. Its surface is covered with deep craters and irregular cavities, giving it a chaotic, porous appearance. Even stranger, Hyperion does not rotate smoothly. Most moons rotate in a predictable way, always showing the same face to the planet they orbit. But Hyperion tumbles unpredictably through space. Its rotation is chaotic. The moon spins irregularly, never settling into a stable orientation. Watching Hyperion rotate is like watching a cosmic rock spinning endlessly in random directions. And beyond these moons lie many more. Small, icy worlds, captured asteroids, fragments left over from ancient collisions, all orbiting Saturn under the influence of its powerful gravity. Together, they form a vast and complex system surrounding the giant planet. Saturn's moons are not simply decorations around the planet. They are entire worlds, some frozen, some stormy, some mysterious, and some potentially capable of supporting environments where life might exist. This makes Saturn's system one of the most fascinating regions in the entire solar system. But even with all these moons, Saturn still holds another breathtaking structure that dominates the planet's appearance: the rings. These rings are the most famous feature of Saturn, stretching across hundreds of thousands of kilometers in space. Yet despite their enormous size, they are incredibly fragile, and their origin remains one of the great mysteries of planetary science. In the next part, we will explore Saturn's rings in detail, because while they appear calm and beautiful from afar, they are actually one of the most dangerous environments in the solar system. An enormous storm of ice and rock moving at incredible speeds around the giant planet. A cosmic structure both breathtaking and deadly. And understanding the rings may reveal something even deeper about the history of Saturn itself. The rings of Saturn. If Saturn were stripped of its rings, it would still be an extraordinary planet. a massive gas giant wrapped in storms, surrounded by dozens of moons and filled with powerful atmospheric forces. But the rings transform Saturn into something entirely different. They turn the planet into one of the most recognizable and breathtaking objects in the entire solar system. From Earth, even a small telescope reveals them, a thin, bright band encircling the golden planet, stretching far into space like a glowing halo. The sight is so striking that it almost looks artificial, as if someone placed a gigantic ornament around the planet. But Saturn's rings are not solid structures. They are far more complex and far more dangerous than they appear. The rings of Saturn are enormous. From one edge to the other, they span more than 280,000 kilometers. That distance is nearly equal to the gap between Earth and the Moon. If the rings were placed around our planet, they would stretch far beyond the Moon's orbit, forming an immense disk across the sky. Yet despite their enormous width, the rings are incredibly thin. In many places, they are only 10 meters thick. Imagine something wider than the distance between Earth and the Moon, yet thinner than a two-story building. This strange combination of size and thinness makes Saturn's rings one of the most delicate large-scale structures in the solar system. But the rings are not smooth. They are made of billions upon billions of individual particles. Some of these particles are tiny grains of ice, no larger than sand. Others are large chunks of frozen water the size of houses, or even mountains. Most of them are made primarily of water ice, reflecting sunlight brilliantly and giving the rings their bright silvery appearance when viewed from space. Each of these particles orbits Saturn independently. They travel around the planet at enormous speeds, sometimes exceeding 100,000 kilometers per hour. Every fragment follows its own path through the ring system, held in orbit by Saturn's gravity, while also interacting with nearby particles. From far away, this motion blends together and looks smooth, but inside the rings, the environment would be chaotic. Imagine flying through a vast field of ice fragments, racing around a giant planet at extreme velocities. Pieces of ice would drift past constantly. Some would collide and shatter. Others would bounce away from each other, sending smaller particles scattering through the surrounding space. The ring system is not static. It is constantly changing. Particles collide, fragments break apart, dust spreads outward, small moons hidden within the rings carve narrow gaps through the material as they orbit Saturn. These tiny moons are known as shepherd moons, and they play a crucial role in shaping the structure of the rings. As they move through the ring system, their gravity pulls on nearby particles, guiding them into narrow bands and maintaining the sharp edges of the rings. Without these shepherd moons, the rings would slowly spread out and become less defined. But even with their help, the rings are not permanent. Scientists believe that Saturn's rings are relatively young compared to the age of the solar system. The solar system formed about 4.5 billion years ago, yet evidence suggests the rings may be only 100 million years old. In cosmic terms, that is extremely recent. So, where did the rings come from? One possibility is that a moon once orbited too close to Saturn. When a moon approaches a giant planet, powerful tidal forces begin to act on it. The side of the moon facing the planet feels a stronger gravitational pull than the far side. This difference stretches the moon. If the moon crosses a certain distance called the Roche limit, Saturn's gravity becomes strong enough to tear it apart. The moon would be ripped into fragments. Those fragments would spread out into orbit, forming a disk of debris around the planet. Over time, collisions between the fragments would grind them down into the mixture of ice particles we see today. Another possibility is that a large comet or asteroid once passed too close to Saturn and was torn apart by the same tidal forces. Either way, the rings may be the remains of a destroyed world. This idea makes Saturn's rings even more haunting. What looks like a delicate halo of ice may actually be the shattered remains of an ancient moon. And the rings themselves are not quiet. They are filled with subtle waves and ripples caused by gravitational interaction between particles, moons, and Saturn itself. These waves move through the rings like ripples across water, creating intricate patterns that scientists can observe with powerful telescopes and spacecraft. When the Cassini spacecraft arrived at Saturn in 2004, it provided the most detailed look at the rings ever achieved. Cassini spent 13 years orbiting Saturn, studying the planet, its moons, and its rings. During that time, it captured images that revealed structures within the rings smaller than a kilometer. Some regions appeared smooth and dense. Others looked chaotic and clumpy. In certain areas, long spiral waves stretched across the rings like enormous cosmic fingerprints. These waves were created by the gravitational pull of nearby moons, gently tugging on the ring particles and shaping their orbits. But the most dramatic discovery came near the end of Cassini's mission. In 2017, the spacecraft performed a series of daring dives between Saturn and the inner edge of the rings. No spacecraft had ever traveled through this region before. Scientists expected the gap to contain a dangerous cloud of particles. Instead, the region was almost empty. Cassini flew through the gap repeatedly, collecting unprecedented data about Saturn's magnetic field, atmosphere, and ring system. Finally, in September 2017, the mission ended in a dramatic finale. Cassini plunged directly into Saturn's atmosphere, burning up as it descended. This final maneuver ensured that the spacecraft would not accidentally contaminate moons like Enceladus or Titan, worlds that might potentially host life. But before it was destroyed, Cassini gave humanity its most detailed look at the rings of Saturn. And what it revealed was astonishing. The rings are slowly disappearing. Tiny particles from the rings are constantly being pulled down into Saturn's atmosphere by gravity and magnetic forces. This phenomenon, known as ring rain, causes the rings to gradually lose material. Over time, the ring system will thin. Eventually, it may disappear entirely. Scientists estimate that Saturn's rings may vanish within 100 million years. Compared to the age of the solar system, this is a short period. This means we are living at a special moment in cosmic history. If intelligent observers existed billions of years ago, Saturn may have had no rings at all. And if intelligent observers exist billions of years in the future, the rings may be gone. Right now, Saturn happens to be wearing them. That thought gives Saturn's rings a strange kind of beauty. They are not eternal, they are temporary, a fleeting spectacle in the long history of the solar system. But Saturn's rings are not just beautiful, they are also incredibly dangerous. Inside the rings, collisions between particles occur constantly. While many of these collisions are gentle, some happen at high speeds. A spacecraft traveling through the rings without proper protection could be damaged or destroyed by impacts with ice fragments. Even small particles moving at tens of thousands of kilometers per hour could puncture spacecraft hulls. This is why missions to Saturn must carefully plan their trajectories. Cassini, for example, avoided the densest regions of the rings during most of its mission. Despite the dangers, the rings remain one of the most mesmerizing sights in space. From orbit around Saturn, they appear as a vast glowing disk stretching across the sky. Sunlight reflects off billions of ice particles, creating a shimmering landscape of light and shadow. Seen from one of Saturn's moons, the rings would dominate the sky like a colossal cosmic arch. They would stretch from horizon to horizon, glowing softly above the frozen surface. Few sights in the solar system could compare. And yet, Saturn itself continues to hold deeper mysteries beyond its rings. Hidden beneath the clouds of the giant planet lies a strange interior filled with exotic materials and extreme pressures. Scientists believe that somewhere deep inside Saturn, the hydrogen ocean surrounding the core may produce one of the most unusual phenomena in planetary science, a rainstorm. But not a rainstorm made of water, a rainstorm made of diamonds. In the next part, we will descend deeper into Saturn's interior to explore the strange physics hidden within the giant planet. Because beneath the storms and clouds lies a world where carbon may crystallize under immense pressure, falling through the atmosphere like glittering stones in the darkness. A place where Saturn literally rains diamonds.
Of diamonds. Saturn's clouds may look soft from space, a pale golden blanket drifting gently across the enormous planet. From far away, the atmosphere appears almost calm, like a quiet ocean of gas reflecting faint sunlight in the darkness of the outer solar system. But beneath those clouds, Saturn hides an environment so extreme that familiar forms of matter begin to behave in strange and unexpected ways. The deeper you descend into the planet, the more alien the world becomes. At the highest visible layers of Saturn's atmosphere, the temperature is already brutally cold, around minus 180 degrees Celsius. But this cold region is only the outer skin of a planet whose interior is full of enormous pressure and rising heat.
Saturn, like Jupiter, still retains heat from its formation billions of years ago. When the solar system was young, Saturn formed from enormous clouds of gas and dust collapsing under gravity. As the planet grew, the energy released by that collapse heated its interior to extreme temperatures. Even today, Saturn continues to slowly contract under its own gravity, releasing additional heat from deep within. This means Saturn actually emits more energy than it receives from the sun. That internal energy slowly rises upward through the planet's massive atmosphere, fueling storms, winds, and convection currents that stretch thousands of kilometers into the sky. But something even stranger happens inside Saturn's atmosphere, something that sounds almost like science fiction. Under the right conditions, Saturn may produce diamond rain. To understand how this happens, we must first look at what Saturn's atmosphere is made of. The planet's atmosphere consists mostly of hydrogen and helium, but mixed within these gases are small amounts of other elements, particularly carbon. Carbon atoms can combine with hydrogen to form methane gas, which is present in Saturn's upper atmosphere. High above the clouds, methane behaves like a normal gas. But deeper in the atmosphere, conditions begin to change dramatically. As pressure increases and temperatures rise, methane molecules begin to break apart. Lightning storms play an important role in this process. Saturn's lightning bolts are incredibly powerful, releasing enormous bursts of energy that can tear methane molecules apart, freeing the carbon atoms inside. Once these carbon atoms are released, they begin forming small particles of soot. These tiny particles drift downward through the atmosphere. As they fall deeper into Saturn, they encounter higher temperatures and crushing pressure. Over time, the carbon particles are compressed into more complex structures. Eventually, they transform into graphite. And as the pressure continues to rise, something extraordinary may happen. The graphite crystals compress further until their atomic structure rearranges itself into something far more rigid. They become diamonds. Tiny diamonds begin to form within Saturn's atmosphere. These diamonds are much smaller than the gemstones we imagine on Earth. Many may be only millimeters across, but once formed, they begin to fall through the atmosphere like glittering rain. Deep within Saturn's clouds, diamond particles may be raining downward continuously. As they fall, the diamonds pass through layers of gas thousands of kilometers thick. But their journey does not end there, because even diamonds cannot survive the deepest layers of Saturn's atmosphere. Further down, temperatures become so extreme that the diamonds eventually melt. The solid crystals dissolve into a strange liquid form of carbon. Scientists believe that beneath the upper atmosphere, there may exist enormous layers where liquid diamond could form. Vast oceans of molten carbon hidden deep inside the planet. It is a bizarre thought. Entire storms of diamonds forming in the clouds, falling through thousands of kilometers of atmosphere, and eventually melting into oceans of liquid carbon deep inside the planet. On Earth, diamonds are rare treasures formed slowly under intense pressure within our planet's crust. On Saturn, they may fall from the sky. But the diamond rain is only one of the strange phenomena inside the giant planet. As we continue descending deeper into Saturn's interior, pressure rises to levels that are almost impossible to imagine. At depths of tens of thousands of kilometers, hydrogen, the most common element in the universe, begins to change. Normally, hydrogen exists as a gas made of individual molecules, but under Saturn's immense pressure, the molecules are squeezed so tightly together that their electrons begin moving freely between atoms. The hydrogen becomes metallic. Metallic hydrogen behaves more like a liquid metal than a gas. It conducts electricity extremely well. It flows like a dense, shimmering ocean surrounding the planet's core. This enormous ocean of metallic hydrogen is responsible for generating Saturn's powerful magnetic field. As the liquid metal moves and circulates inside the planet, and it creates electric currents. These currents generate a magnetic field that extends millions of kilometers into space. This invisible magnetic bubble surrounds Saturn, protecting the planet from charged particles carried by the solar wind. But the magnetic field also creates powerful radiation belts around the planet. Charged particles become trapped within the magnetic field and spiral around Saturn at incredible speeds. These particles form invisible rings of radiation that can be extremely dangerous to spacecraft. Saturn's magnetic field is enormous. It stretches so far into space that it interacts with the planet's rings and moons, shaping their environments and creating spectacular auroras near Saturn's poles. These auroras are similar to Earth's northern lights,
but far larger.
Seen from orbit, Saturn's auroras appear as glowing rings of light surrounding the poles, shimmering in shades of green and purple as charged particles slam into the upper atmosphere. These auroras can span areas larger than Earth itself. But deep beneath all these layers, the storms, the diamond rain, the metallic hydrogen ocean, lies Saturn's core. The core of Saturn remains one of the greatest mysteries in planetary science. Scientists believe the core is made of heavy elements such as rock, ice, and metal, but its exact size and structure remain uncertain. Some models suggest the core may be relatively small, perhaps 10 to 20 times the mass of Earth.
Other models suggest the core may not be solid at all, but instead a fuzzy mixture of rock, ice, and metallic hydrogen blending gradually into the surrounding layers. Unlike Earth, Saturn does not have a clearly defined center. Instead, the interior transitions gradually from gas to liquid to exotic metallic states. It is more like descending into a vast cosmic ocean than entering the interior of a solid world. And the deeper you go, the more hostile the environment becomes. Temperatures soar into the thousands of degrees. Pressures rise millions of times higher than those on Earth. No spacecraft built by humanity could survive those conditions. Saturn's interior remains forever beyond our reach. Yet even with all these terrifying features, the crushing pressure, the violent storms, the strange metallic oceans, Saturn still possesses an almost haunting beauty. Seen from space, the planet glows softly in sunlight. The rings shimmer like frozen waves circling the giant world. The moons drift gracefully through the darkness. But beneath that beauty lies one of the most extreme environments in the solar system. A planet where storms rage for decades, where lightning explodes with unimaginable energy, where diamonds may fall through endless clouds, and where exotic forms of matter exist under crushing pressure deep within the giant world. Saturn may appear calm and elegant from afar,
but inside, it is a realm of violence and strange physics, a place where the familiar rules of planets give way to something far more alien. And yet Saturn still holds another terrifying feature. Because Saturn is not only a giant world, it is also a gravitational powerhouse capable of shaping everything around it. Its gravity dominates a vast region of space. It controls its rings, it commands its moons, and it influences the movement of countless objects drifting through the outer solar system. In the next part, we will explore how Saturn's enormous gravity shapes the region around it, and how this giant planet became one of the most powerful forces in the architecture of our solar system. Part 6, 2000. Part 6, The Endless Storms of Saturn. Far above the invisible surface of Saturn, the atmosphere never rests. There is no solid ground beneath the clouds, no mountains to break the wind, no continents to slow the storms. Only endless layers of gas stretching thousands of kilometers deep. In this environment, storms can grow to unimaginable scales, fueled by heat rising from the planet's interior and winds that circle the entire world. And when these storms appear, they do not behave like the storms on Earth. They become planetary monsters. Saturn's atmosphere is one of the most violent environments in the entire solar system. Winds near the equator can reach speeds of 1,800 kilometers per hour, far faster than the most powerful hurricanes on Earth. Entire bands of clouds race around the planet like rivers of gas, wrapping around Saturn, an enormous belt that never stops moving. But sometimes, something even more terrifying happens. Every few decades, Saturn unleashes what scientists call a great white storm. These storms are among the largest weather events ever observed on any planet. When one of these storms begins, it appears as a bright white spot in Saturn's clouds. But within days, it expands into a colossal system, stretching tens of thousands of kilometers across the planet's atmosphere. The storm rapidly grows until it becomes so large that it wraps around the entire planet. Imagine a hurricane so powerful that it circles the Earth. That is what Saturn can produce. The most recent Great White Storm was observed in 2010 when spacecraft orbiting Saturn began detecting unusual activity in the planet's northern hemisphere. At first, it looked like a small disturbance in the cloud layers. But within weeks, the storm exploded in size. It grew into a massive cloud system, stretching more than 300,000 kilometers around Saturn's atmosphere. Lightning flashes began erupting inside the storm, each one thousands of times more powerful than lightning on Earth. Radio signals detected by spacecraft revealed that these lightning bolts were among the strongest electrical discharges ever recorded in the solar system. These storms do not last hours, they last months. The 2010 storm continued raging for more than 7 months, slowly spreading across Saturn's atmosphere until it finally began to fade. But even after it disappeared from view, the disturbance it created remained in Saturn's cloud layers for years, and scientists still do not fully understand why these storms appear. One theory suggests that heat rising from Saturn's deep interior slowly builds energy inside the atmosphere. Over time, this energy accumulates beneath layers of clouds until something finally triggers a massive eruption of convection. When that happens, the planet releases decades of stored energy in a single gigantic storm. But Saturn's storms are not limited to these rare events. Across the planet's atmosphere, smaller storms constantly form and disappear. Some of them stretch thousands of kilometers across the clouds, twisting and swirling through the gas layers like giant atmospheric whirlpools. And unlike storms on Earth, these systems can last years. One example is the enormous jet streams that dominate Saturn's atmosphere. These fast-moving bands of gas create alternating zones of calm and turbulence that circle the entire planet. Within these bands, storms can become trapped, carried along by the high-speed winds as they circle Saturn again and again. In some cases, storms have been observed traveling around the planet multiple times before fading away. But perhaps the strangest atmospheric feature on Saturn lies at the North Pole. Here, something extraordinary exists. A gigantic hexagon-shaped storm, unlike any weather system ever seen on Earth. Discovered during spacecraft observations in the 1980s and later studied in detail by the Cassini mission, Saturn's North Pole is dominated by a perfectly shaped six-sided jet stream. This hexagonal pattern stretches more than 30,000 kilometers across, large enough to fit 4 Earths inside it, and it does not move. The hexagon spins in place, rotating with Saturn's atmosphere while maintaining its geometric shape. At the center of the hexagon lies another storm, a powerful polar vortex with winds reaching extreme speeds. This vortex resembles a giant hurricane, but one that has been raging continuously for decades. Scientists still debate what creates the hexagon.
Some believe it is caused by the interaction between fast-moving jet streams at different latitudes. Laboratory experiments have shown that rotating fluids can sometimes produce polygon shapes when different flow speeds collide. But Saturn's hexagon is far larger and far more stable than anything produced in experiments on Earth, which has remained in place for at least 40 years, ever since it was first discovered. And it may have existed far longer than that. Meanwhile, Saturn's south pole hosts another enormous storm, a giant vortex similar to a hurricane, but far more powerful. Unlike the hexagon, the southern storm is circular, with a massive eye at its center.
Spacecraft images show towering cloud walls rising around this eye, forming a structure that resembles a gigantic hurricane thousands of kilometers across. But this storm never makes landfall. It has nowhere to go. It simply spins endlessly above Saturn's pole. Lightning storms also rage deep within Saturn's atmosphere. These electrical storms occur in regions where water clouds exist far below the visible cloud tops, as convection carries material upward through the atmosphere. Powerful lightning bolts ignite inside the storm systems. These lightning flashes are so strong that spacecraft can detect their radio emissions from millions of kilometers away. Some of these electrical storms produce bursts of radio waves that repeat every few seconds for days or weeks at a time.
From space, Saturn sometimes appears calm, but beneath the golden cloud layers, the planet is constantly roaring with violent atmospheric activity, wind, lightning, storms, all of it powered by the heat trapped deep inside the planet. Saturn radiates more energy into space than it receives from the sun. This extra heat comes from the slow compression of the planet's interior, where gravitational forces generate energy as the planet gradually shrinks. This internal heat drives convection throughout Saturn's atmosphere, fueling the storms and winds that shape the planet's weather. And because Saturn is so large, these processes occur on a scale that dwarfs anything on Earth. Storm systems larger than continents, winds faster than jet aircraft,
lightning bolts powerful enough to outshine entire regions of the atmosphere, all swirling endlessly through Saturn's thick clouds. And yet, despite decades of observation, much of Saturn's atmospheric behavior remains mysterious. Why do the great white storms appear every few decades? Why does the hexagon remain stable for so long? What exactly lies beneath the visible cloud layers? These questions remain unanswered. But one thing is certain: Saturn's atmosphere is not a peaceful ocean of clouds. It is a world of relentless storms, a planet where weather never truly ends. And in the next part, we will explore something even more terrifying: the invisible radiation environment surrounding Saturn, and how its magnetic field creates one of the most dangerous regions of space in the solar system. Part 7, 2000, Final. Part 7, The Invisible Radiation Trap. Far beyond the shimmering rings and golden clouds of Saturn lies something you cannot see, something far more dangerous than storms. An invisible cage of energy surrounds the planet, a vast magnetic environment capable of trapping deadly radiation for millions of kilometers into space. This region is known as Saturn's magnetosphere, and it is one of the most extreme environments in the solar system. At first glance, Saturn appears calm and distant, floating quietly in the darkness beyond the asteroid belt. But beneath this peaceful appearance lies a powerful magnetic engine. Deep inside the planet, layers of liquid metallic hydrogen move under intense pressure. These electrically conducting fluids churn and rotate as Saturn spins, generating an enormous magnetic field that stretches far into space. This field acts like a giant invisible shield, but it is also a trap. Charged particles from the sun, protons, electrons, and other energetic fragments carried by the solar wind become captured by Saturn's magnetic field. Once trapped, these particles spiral along invisible magnetic lines, racing around the planet at incredible speeds.
Over time, more and more particles accumulate, and soon, a massive radiation environment forms around the planet. These zones of trapped radiation are similar to the Van Allen belts that surround Earth. But Saturn's radiation system is far larger and far more complex. In some regions, particles reach such extreme energies that they can destroy spacecraft electronics within minutes. If a human astronaut somehow found themselves inside the most intense radiation zones without protection, the exposure would be fatal. But Saturn's radiation environment is not simply a ring of particles surrounding the planet. It is constantly changing. The magnetosphere expands and contracts depending on the pressure of the solar wind.
When powerful bursts of energy from the sun arrive, Saturn's magnetic bubble can compress suddenly, triggering enormous disturbances throughout the entire system. These disturbances create vast electrical currents flowing through space. They produce powerful auroras above Saturn's poles, and they send waves of energy racing along magnetic field lines, connecting the planet to its moons. In fact, Saturn's magnetosphere is so large that it can extend over 1 million kilometers into space on the side facing the sun. But on the opposite side, it stretches even farther. Behind the planet, the magnetosphere forms a gigantic magnetic tail that can extend tens of millions of kilometers into space. Longer than the distance between Earth and the moon, many times over. Within this invisible structure, energy constantly flows and shifts. Charged particles move along magnetic pathways, bouncing between the northern and southern hemispheres of the planet. Some of these particles crash into Saturn's upper atmosphere near the poles. When they do, something beautiful happens. The sky above Saturn begins to glow. Massive curtains of light form above the planet's polar regions, creating enormous auroras, similar to the northern lights seen on Earth, but far more powerful. Saturn's auroras can stretch across entire hemispheres, forming glowing rings of energy thousands of kilometers wide. These displays are fueled by the same radiation particles trapped in Saturn's magnetosphere. As the particles plunge into the atmosphere, they collide with atoms of hydrogen and helium, releasing bursts of light. But unlike Earth's auroras, Saturn's displays can be triggered by many different sources. Sometimes the solar wind drives them. Sometimes storms inside Saturn's atmosphere disturb the magnetic field. And sometimes the planet's moons themselves play a role. One moon in particular has a profound influence on Saturn's radiation environment: Enceladus. This small icy world, only about 500 kilometers across, constantly sprays water vapor into space from massive geysers near its south pole. These plumes shoot particles hundreds of kilometers above the moon's surface before they escape into orbit around Saturn. Once there, the particles become trapped inside Saturn's magnetic field. They slowly spread outward, forming a vast cloud of ionized gas that fills the region around the planet. This cloud, known as the Enceladus plasma torus, feeds Saturn's magnetosphere with fresh particles, and those particles eventually become part of the radiation belt surrounding the planet. But the magnetosphere does not simply trap particles, it accelerates them. Within Saturn's magnetic environment, powerful electromagnetic waves can push particles to enormous speeds. These waves interact with charged particles in complex ways, transferring energy and boosting their velocities until they reach extreme energies. Some particles eventually escape along the magnetic tail behind Saturn. Others plunge into the atmosphere, producing auroras. But many remain trapped for long periods of time, circling the planet again and again. Spacecraft that travel through Saturn's magnetosphere must navigate this dangerous environment carefully. The Cassini spacecraft, which spent 13 years orbiting Saturn, repeatedly passed through different regions of the radiation belts. Engineers carefully designed Cassini's electronics to withstand these harsh conditions. Even so, the spacecraft had to follow carefully planned trajectories to avoid the most intense radiation zones. Without these precautions, sensitive instruments could have been permanently damaged. Yet Saturn's radiation environment is still not fully understood. One mystery involves the unexpected weakness of the inner radiation belts. Scientists once believed Saturn's radiation belts would be extremely intense close to the planet. But observations from Cassini revealed that Saturn's rings actually absorb many high-energy particles. The rings act like a protective barrier, sweeping away radiation that might otherwise accumulate near the planet. This means that the rings themselves help shape Saturn's magnetosphere. In a strange way, the rings protect the inner region around the planet from becoming even more dangerous. But beyond the rings, radiation levels increase dramatically. Charged particles accelerate through space, guided by magnetic forces that humans cannot see, but spacecraft instruments can measure. The magnetosphere also interacts with Saturn's moons in fascinating ways. As moons like Titan, Rhea, and Dione orbit through the magnetic environment, they disturb the flow of particles around them. Some moons absorb radiation, leaving behind invisible shadows in the particle belts. Others generate electrical currents that ripple through the magnetic field. Each moon becomes part of the magnetospheric system, and together they create a dynamic environment where gravity, magnetism, and radiation constantly interact. But the most remarkable thing about Saturn's magnetosphere may be its sheer scale. If it were visible from Earth, Saturn's magnetic bubble would appear far larger than the moon in our sky. It would dominate the entire region around the planet, an enormous invisible structure stretching millions of kilometers across, and within it, charged particles race endlessly through space, a silent storm of radiation, invisible, relentless, deadly. Saturn's rings may be beautiful, its clouds may appear calm from a distance, but hidden around the planet is an energy field powerful enough to trap radiation, shape the movement of moons, and generate some of the most spectacular auroras in the solar system. The deeper scientists look into Saturn's magnetic environment, the more they realize how complex this distant giant truly is. Because Saturn is not simply a planet, it is a system. A world surrounded by storms, radiation, and magnetic forces on a scale almost impossible to imagine.
And yet, even this is not the most frightening thing about Saturn. In the next part, we will explore something even stranger. The mysterious sounds of Saturn and the strange radio signals that scientists have detected coming from this distant giant. The deep interior of Saturn. From a distance, Saturn appears peaceful, a golden world wrapped in delicate rings, slowly turning in the darkness beyond Mars and Jupiter. But beneath those calm clouds lies a place so extreme that no spacecraft has ever seen it directly. Saturn has no solid surface. If you were somehow able to descend toward the planet, there would be no ground waiting beneath the clouds. Instead, the atmosphere would simply grow thicker and heavier as you move deeper into the planet. At first, you would encounter the upper cloud layers, pale bands of ammonia ice drifting through Saturn's atmosphere. These clouds move rapidly, pushed by winds faster than hurricanes on Earth. Below them lie deeper clouds made of ammonium hydrosulfide.
Below those, even deeper still, are clouds of water, ice, and vapor. Regions where enormous lightning storms rage through the dense atmosphere. But this is only the beginning. As you descend deeper into Saturn, the pressure increases rapidly. Within a few hundred kilometers beneath the cloud tops, the atmosphere becomes so dense that it begins behaving less like gas and more like liquid. Temperatures rise dramatically, and the hydrogen and helium that make up most of the planet begin to compress under their own weight. At this point, the environment would already be deadly. The pressure would crush any known spacecraft. Temperatures would rise high enough to melt most metals, and the violent turbulence of Saturn's deep atmosphere would make stable descent nearly impossible. But even deeper mysteries lie far below. Saturn is primarily made of hydrogen, the simplest and most abundant element in the universe. But under the immense pressure inside the planet, hydrogen begins to behave in strange ways. Far below the atmosphere, something remarkable happens. The hydrogen transforms. Instead of existing as a normal gas, it becomes a strange state of matter known as liquid metallic hydrogen. In this form, hydrogen behaves like a liquid metal. Its electrons move freely, allowing it to conduct electricity, just like copper or iron. But unlike metals on Earth, this material exists only under extreme pressure, millions of times greater than the pressure at Earth's surface. This metallic hydrogen layer is believed to make up a large portion of Saturn's interior.
And it is this layer that powers Saturn's enormous magnetic field. As Saturn rotates, completing a full rotation in just over 10 hours, the metallic hydrogen deep inside the planet flows and circulates. These movements generate electrical currents, which in turn produce Saturn's powerful magnetic field. This invisible field extends millions of kilometers into space, shaping the planet's magnetosphere and trapping charged particles from the solar wind. But the metallic hydrogen ocean is not the deepest part of Saturn. Even farther down lies something even more mysterious. At the very center of the planet, scientists believe Saturn contains a dense core made of heavier elements. Materials like rock, metal, and ice left over from the early formation of the solar system.
This core may be roughly 10 to 20 times the mass of Earth, but it does not resemble the solid rocky core of a terrestrial planet like Earth or Mars. Instead, the core may be partially dissolved into the surrounding layers, creating a strange mixture of heavy materials blended with hydrogen and helium. Some scientists believe Saturn's core could even be fuzzy, gradually blending into the surrounding metallic hydrogen rather than forming a sharply defined boundary. This idea comes from data collected by the Cassini spacecraft, which spent 13 years orbiting Saturn before its mission ended in 2017. During the final phase of the mission, Cassini performed a series of daring orbits that carried it between Saturn and its rings.
These close passes allowed scientists to measure tiny changes in the spacecraft's motion caused by Saturn's gravitational field. By studying these subtle variations, researchers were able to learn more about how mass is distributed inside the planet. And the results were surprising. Instead of finding evidence for a small, solid core, scientists discovered that Saturn's interior may be far more complex. The planet's heavy elements appear to be spread across a much larger region than previously thought. This suggests that Saturn's core may extend across tens of thousands of kilometers, gradually mixing into the surrounding hydrogen layers. If true, this would mean Saturn does not have a clearly defined center.
Instead, the planet's interior may resemble a vast gradient of materials, from hydrogen gas at the top to metallic hydrogen deeper down, eventually blending into a dense mixture of heavy elements near the center. And throughout this enormous structure, extreme conditions dominate. Pressures in Saturn's deepest layers may reach millions of times greater than the pressure at Earth's surface. Temperatures may rise above 11,000 degrees Celsius, hotter than the surface of the sun. Under these conditions, matter behaves in ways that scientists are still trying to understand. Atoms are squeezed so tightly together that their normal structures break down. Exotic states of matter appear, including materials that exist nowhere naturally on Earth. One of the strangest processes believed to occur inside Saturn is something known as helium rain. Saturn is composed mostly of hydrogen and helium, the same elements that make up the sun. But under the extreme pressures inside the planet, helium may separate from hydrogen in certain layers of the interior. When this happens, droplets of liquid helium begin forming within the metallic hydrogen ocean. These droplets slowly sink deeper into the planet. As they fall, they release gravitational energy, generating heat inside Saturn's interior. Scientists believe this process helps explain an important mystery about the planet. Saturn emits more heat than it receives from the sun. Even though it orbits nearly 10 times farther from the sun than Earth does, Saturn radiates significant amounts of internal energy into space. This extra heat may come partly from helium rain occurring deep within the planet. Imagine a constant drizzle of helium droplets falling through an ocean of metallic hydrogen thousands of kilometers deep. An alien weather system completely unlike anything on Earth. But the deep interior of Saturn remains largely unknown. No probe has ever descended far into the planet's atmosphere. The extreme pressure and temperature would destroy any spacecraft long before it reached the deeper layers. Even the Galileo probe, which entered Jupiter's atmosphere in 1995, survived for less than an hour before being crushed by the intense pressure. Saturn's atmosphere would present similar challenges. For now, scientists must rely on indirect observations, measuring gravity, magnetic fields, and atmospheric behavior to infer what lies beneath the clouds. But each new mission reveals new clues, and each clue suggests that Saturn is even more complex than we once imagined. A planet with no solid surface, an ocean of metallic hydrogen hidden beneath storms, helium rain falling through alien oceans, a vast interior where matter exists in extreme states beyond human experience, all hidden beneath the golden clouds we see from space. Yet even this incredible interior may not be the most mysterious aspect of Saturn, because Saturn is not only defined by what lies inside the planet, it is also defined by what surrounds it. The rings, those enormous glowing structures that stretch hundreds of thousands of kilometers across space, beautiful from a distance, but far stranger than they first appear. In the final part of our journey, we will explore the true nature of Saturn's rings, how they formed, why they may be disappearing, and what makes them one of the most astonishing structures in the entire solar system. The fragile majesty of Saturn's rings. When most people imagine Saturn, the first thing that comes to mind is not the planet itself. It is the rings. Those enormous glowing bands of ice and dust that stretch outward from the planet like a gigantic halo. Seen through a telescope, Saturn's rings appear smooth and elegant, a perfect cosmic ornament decorating the giant world. But the truth is far stranger. Saturn's rings are not solid, they are not smooth, and they are not permanent. They are a vast, chaotic ocean of ice, millions upon millions of individual pieces, some as small as grains of sand, others as large as mountains, all orbiting Saturn together in an enormous disk. From far away, the rings appear like a thin sheet of glowing light. But if you could move closer, you would see something astonishing. Each ring is made of countless icy fragments racing around the planet at tremendous speeds. Some chunks are only a few centimeters wide, others are hundreds of meters across, and they are all moving at speeds of tens of thousands of kilometers per hour. Yet despite these enormous speeds, the particles rarely collide violently. Instead, they move in carefully balanced orbits, guided by Saturn's gravity. To understand how the rings work, imagine billions of tiny moons orbiting the planet side by side. Each particle follows its own path around Saturn, forming a complex system of streams and gaps that together create the beautiful ring structure we see from Earth. Saturn actually has 7 main rings, labeled from the inside outward as D, C, B, A, F, G, and E. The B ring is the brightest and most massive. The A ring lies just outside it, separated by a large gap known as the Cassini division. For centuries, astronomers believed this dark gap was simply an empty space. But spacecraft observations revealed something surprising. The Cassini division is not empty at all. It contains particles, just far fewer of them than the surrounding rings. The reason for this gap lies in the gravitational influence of Saturn's moons. Certain moons orbit the planet at distances that create gravitational resonances within the rings. These resonances disturb the orbits of ring particles, clearing out certain regions and creating the dark gaps we observe. One moon in particular, Mimas, plays a major role in shaping the Cassini division. Every time ring particles attempt to orbit Saturn in this region, Mimas's gravitational pull slightly alters their paths. Over time, these repeated disturbances push particles away from the region, maintaining the gap. But Saturn's rings contain far more than simple gaps. Hidden within the rings are countless delicate structures. Thin ringlets, waves of particles, spiral patterns stretching thousands of kilometers. Some of these patterns are created by small moons embedded within the rings themselves. These tiny worlds, known as shepherd moons, act like cosmic shepherds guiding flocks of icy particles along narrow paths. Two of the most famous shepherd moons are Prometheus and Pandora, which orbit near Saturn's F ring. As they move along their orbits, their gravity pulls on nearby ring particles, creating twisting streams and strange braided structures inside the ring. The result is one of the most dynamic environments in the entire solar system. Cassini spacecraft images reveal that Saturn's rings are constantly changing. Particles collide and bounce. Clumps form and dissolve. Small waves ripple through the rings like vibrations in water. In some regions, the rings resemble stormy seas frozen in time. Yet despite their enormous size, Saturn's rings are surprisingly thin. If you could view them from the side, they would appear almost invisible. Most parts of the ring system are only about 10 meters thick. To put that into perspective, imagine a disk hundreds of thousands of kilometers wide, but thinner than the height of a small building. And yet, even this delicate structure contains enormous amounts of material. Scientists estimate that the total mass of Saturn's rings may be roughly equal to that of a small moon, about 200 kilometers across. But where did all this material come from? For centuries, astronomers debated the origin of Saturn's rings. Some believed the rings formed at the same time as Saturn itself, leftovers from the giant disk of gas and dust that created the planets billions of years ago. Others believed the rings formed much later, perhaps from the destruction of a moon. One possible explanation involves something known as the Roche limit. This is the distance from a planet where tidal forces become strong enough to tear apart a moon held together by gravity. If a large, icy moon once wandered too close to Saturn, the planet's gravitational forces could have ripped it apart. The fragments of that shattered moon would then spread out into orbit, eventually forming the rings we see today. Recent evidence suggests that Saturn's rings may actually be much younger than the planet itself. Data collected by the Cassini spacecraft indicates that the rings may be only 100 million years old. That might sound ancient. But compared to the 4.5 billion year age of the solar system, it is surprisingly young. If this is true, it means Saturn did not always have rings. There may have been a time when the giant planet looked completely different, a plain gas giant without the beautiful halo we see today. And even more surprising, the rings may not last forever. Saturn's rings are slowly disappearing. Observations from spacecraft and telescopes have revealed a phenomenon known as ring rain. Tiny particles from the rings are gradually being pulled into Saturn's atmosphere by the planet's magnetic field. As these particles fall, they interact with Saturn's upper atmosphere, producing faint chemical signatures that scientists can detect. This process is slowly draining material from the rings. Some estimates suggest that Saturn could lose its rings within 100 million years. In cosmic terms, that is incredibly fast. It means we may be living at a special moment in the history of the solar system, a time when Saturn's rings are at their most spectacular. Billions of years ago, they may not have existed. Millions of years in the future, they may vanish again. A temporary cosmic masterpiece. But even as the rings slowly fade, they continue shaping the region around Saturn. Many of the planet's moons interact with the rings in fascinating ways. Some moons help maintain the ring's structure. Others may have formed from ring material itself. In fact, Some scientists believe that Saturn's inner moons may have grown directly out of the rings, slowly gathering material over millions of years. This means Saturn's ring system may be constantly evolving, creating new moons while losing material at the same time, a delicate balance between creation and destruction. And when viewed from space, the rings remain one of the most breathtaking sights in the universe. Imagine standing on a spacecraft drifting just above the ring plane. Above you rises the enormous golden sphere of Saturn, filling half the sky. Below you stretches an endless field of glittering ice particles, reflecting sunlight like countless diamonds scattered through space. Some pieces spin slowly as they orbit the planet. Others collide gently, drifting apart again in silence. No sound, no wind, only the quiet motion of billions of icy fragments circling a giant world. It is one of the most beautiful scenes in the solar system. But beauty can be deceiving because the same gravity that created this magnificent structure also ensures that it cannot last forever. Slowly, patiently, Saturn is reclaiming its rings, and someday, far in the future, the giant planet may once again stand alone in space. A golden world without its shining crown.
In the final part of our journey, we will bring together everything we have learned about Saturn and ask a final question. Why does this distant planet inspire both awe and fear? And what makes Saturn one of the most mysterious and intimidating worlds in our cosmic neighborhood? The dark majesty of Saturn. Saturn has fascinated humanity for centuries. Long before spacecraft explored the outer solar system, ancient astronomers watched this distant planet slowly move across the night sky. Through early telescopes, Saturn appeared strange, not a simple point of light like other planets, but something unusual, a planet with ears, as Galileo once described it. Later observations revealed the truth. Saturn was surrounded by rings, unlike anything seen anywhere else in the solar system. For hundreds of years, Saturn remained a distant mystery. But as science advanced and spacecraft finally traveled to the outer planets, Saturn began revealing its secrets. And the more scientists discovered, the more astonishing this world became. Because Saturn is not simply a planet, it is an entire system, a massive gas giant surrounded by dozens of moons, glowing rings, violent storms, and powerful magnetic forces. A place where gravity shapes enormous structures and where the laws of physics unfold on scales almost impossible to imagine. Yet behind all of this beauty lies something darker. Saturn is a world of extremes.
Its winds scream across the atmosphere faster than the strongest hurricanes on Earth. Lightning storms explode deep within its clouds, unleashing electrical power greater than anything our planet can produce. At its north pole, a gigantic hexagon-shaped storm spins endlessly, a geometric mystery large enough to swallow several Earths. Deep beneath the clouds, the planet hides oceans of metallic hydrogen, where matter behaves like liquid metal under crushing pressure. Temperatures there rise hotter than the surface of the sun, and helium droplets may fall like rain through alien oceans thousands of kilometers deep. All of this occurs inside a planet with no solid surface. A world where you could fall forever into deeper and deeper layers of gas. And surrounding this enormous planet is one of the most breathtaking structures in the solar system, the rings. From Earth, they appear delicate and peaceful, thin bands of light circling the planet like a celestial ornament. But in reality, They are a vast disk of icy debris stretching hundreds of thousands of kilometers across space. Billions of fragments race around Saturn at tremendous speeds, forming waves, gaps, and twisting streams shaped by gravity. They are beautiful, yet they are fragile. Slowly, particle by particle, Saturn is reclaiming its rings. Tiny grains of ice are falling into the planet's atmosphere in a process known as ring rain. Over millions of years, the brilliant halo surrounding Saturn may fade away completely. One day, the giant planet could stand alone again, a silent world without its crown. But perhaps the most fascinating aspect of Saturn is not what we can see. It is what we cannot. The invisible forces surrounding the planet. Saturn's magnetosphere stretches millions of kilometers into space, trapping high-energy particles and shaping the movement of its moons. Inside this magnetic environment, radiation storms rage silently, invisible yet powerful enough to damage spacecraft. Auroras blaze above the planet's poles, enormous curtains of glowing light created by charged particles colliding with Saturn's atmosphere. These displays are far larger than the northern lights on Earth. Entire hemispheres can glow with shifting waves of color. And all of this occurs around a world nearly 10 times farther from the sun than Earth. Yet Saturn is not alone. Orbiting this giant planet are more than 140 moons, each with its own unique story. There is Titan, a world larger than Mercury with lakes of liquid methane and rivers flowing across its frozen surface. There is Enceladus, a small icy moon that sprays enormous geysers of water into space, hinting at a hidden ocean beneath its frozen crust. And there are countless smaller moons scattered throughout Saturn's rings and orbiting the planet in distant paths. Together, these moons form a miniature planetary system, a cosmic family shaped by Saturn's gravity. When the Cassini spacecraft arrived at Saturn in 2004, it began one of the most ambitious planetary missions ever attempted. For more than a decade, Cassini explored the Saturn system in extraordinary detail. It flew through the rings, it photographed storms raging across the atmosphere, it discovered towering geysers erupting from Enceladus, and it revealed new mysteries about Titan's lakes and weather. Cassini transformed our understanding of Saturn. But in 2017, the mission came to an end. Engineers made the difficult decision to send the spacecraft into Saturn's atmosphere, where it burned up and vanished. This final maneuver ensured that Cassini would not accidentally contaminate Saturn's moons with Earth microbes. As it plunged into the planet's atmosphere, Cassini transmitted its final data back to Earth. For the last time, the spacecraft felt Saturn's gravity pulling it deeper into the clouds. Then the signal disappeared. Cassini became part of Saturn itself. Even now, years later, scientists continue studying the enormous amount of data the spacecraft returned. Each new analysis reveals more about this distant giant. Yet despite everything we have learned, Saturn remains mysterious. We still do not fully understand the processes shaping its interior. We do not know exactly how its rings formed. We are still exploring the possibility that one of its moons may contain conditions suitable for life. The Saturn system continues to challenge our understanding of planetary science. But perhaps the most powerful reason Saturn captivates us is the feeling it inspires. Saturn is beautiful, yet is also intimidating. A world of storms, radiation, crushing gravity, and alien oceans hidden beneath layers of clouds. It reminds us that the universe is vast and strange, that the planets beyond Earth operate under conditions far more extreme than anything we experience here. And that even after centuries of observation and exploration, the cosmos still holds mysteries waiting to be uncovered. So, when you look up at the night sky and see Saturn shining faintly among the stars, remember what lies behind that distant point of light. A giant world, a system of rings and moons, a planet where storms rage for months, where hexagonal hurricanes spin above the poles, and where metallic oceans lie hidden beneath golden clouds. A place where gravity shapes structures larger than entire worlds, and perhaps one of the most fascinating and most frightening planets in our solar system. Thank you for exploring this incredible journey with stellar depth. And if you enjoy discovering the hidden wonders of the universe, don't forget to subscribe as we continue uncovering the mysteries of space, one cosmic story at a time. The future of Saturn. Saturn has existed for billions of years, long before Earth formed oceans, before life appeared, before the first stars visible to the human eye were born. Saturn was already there, a giant world slowly orbiting the young sun in the outer darkness of the solar system. But even planets do not last forever. Everything in the universe changes over time. Stars evolve, galaxies collide, planets transform, and Saturn, despite its enormous size, is no exception. To understand Saturn's future, scientists must first understand its past. Saturn formed roughly 4.5 billion years ago, during the chaotic birth of the solar system. At that time, a massive disk of gas and dust surrounded the young sun. Within this swirling disk, tiny grains of material began clumping together. Some clumps grew larger and larger, eventually forming the cores of the giant planets. Saturn likely began as a rocky and icy core many times the mass of Earth. Once that core became massive enough, it began pulling enormous amounts of hydrogen and helium gas from the surrounding disk. In a relatively short time, perhaps only a few million years, Saturn became a giant planet, a massive sphere of gas hundreds of thousands of kilometers wide. But the solar system was not peaceful during those early years. Planets were still moving into their final orbits. Asteroids and comets frequently collided with young worlds. Moons were captured, destroyed, and reshaped by gravity. During this chaotic time, Saturn's ring system may have formed. Some scientists believe the rings could have originated from a moon that wandered too close to the planet. Saturn's gravity would have torn that moon apart, scattering its icy fragments into orbit. Over time, those fragments spread into the magnificent rings we see today. Yet the rings themselves are temporary. One of the most fascinating discoveries made by the Cassini spacecraft was that Saturn's rings are slowly disappearing. Tiny particles of ice and dust are constantly being pulled toward the planet by Saturn's magnetic field. This process, known as ring rain, causes material from the rings to fall into the upper atmosphere. Scientists estimate that Saturn may lose enough ring material every day to fill a large swimming pool. It may not sound dramatic, but over millions of years it adds up. If current estimates are correct, Saturn's rings may survive only another 100 million years. Eventually, the bright disk of ice that surrounds the planet could fade away completely. Saturn would still exist, but it would look very different from the planet we know today. Without its rings, Saturn would appear as a simple gas giant, perhaps not much different from Jupiter when seen from afar. But Saturn's rings are not the only feature that will change. Deep inside the planet, Saturn is slowly evolving. Gas giants like Saturn gradually cool over time. The heat trapped inside the planet during its formation slowly escapes into space. This cooling process happens very slowly, but over billions of years, it changes the planet's internal structure. One of the processes believed to occur deep inside Saturn is helium rain. In certain layers of the planet, helium separates from hydrogen and forms droplets. These droplets slowly sink toward the planet's center, releasing energy as they fall. This process helps explain why Saturn still emits significant amounts of heat into space. But eventually, even this process will end. As Saturn continues cooling over billions of years, its interior will gradually become more stable. Storm activity may decrease. The planet's internal heat will slowly fade, and Saturn may eventually become a quieter, colder world. Yet the greatest change to Saturn's future will come not from within the planet, but from the sun. Right now, the sun is a stable star, but stars do not remain stable forever. In about 5 billion years, the sun will begin exhausting the hydrogen fuel in its core. As this happens, the sun will expand dramatically, transforming into a red giant star. During this phase, the sun could expand far enough to swallow the inner planets, possibly including Mercury, Venus, and even Earth. The outer planets, including Saturn, will not be swallowed, but they will still experience enormous changes. As the sun expands, it will grow far brighter than it is today. Temperatures throughout the solar system will increase dramatically. Saturn's icy moons could begin melting. Frozen worlds like Enceladus, Rhea, and even Titan might experience dramatic transformations. Titan, with its thick atmosphere and lakes of methane, could warm enough for new chemical processes to occur on its surface. Some scientists have even suggested that Titan might briefly become one of the most habitable places in the solar system during this distant future. Meanwhile, Saturn's atmosphere will also change. The increased solar radiation may alter the chemistry of the planet's upper clouds. Storm patterns could evolve. The rings, if they still exist at that time, might become unstable under the new gravitational conditions created by the sun's expansion. But eventually, the red giant phase will end. The sun will shed its outer layers into space, forming a glowing cloud known as a planetary nebula. At the center of this nebula, the remaining core of the sun will collapse into a white dwarf, a small, extremely dense stellar remnant. By this time, the solar system will look completely different. The inner planets may be gone. Asteroid belts will be disturbed. Many moons could be lost or altered, but Saturn will likely survive. The giant planet will continue orbiting the dying sun, now a faint white dwarf, in the cold outer reaches of the solar system. Without the sun's strong radiation, temperatures throughout the solar system will fall dramatically. Saturn will become a dark, frozen giant drifting through deep space. Its storms may eventually fade. Its atmosphere may settle into quieter patterns, and if the rings have already disappeared, Saturn will appear as a simple golden sphere surrounded by its moons. But even in this distant future, Saturn will remain a reminder of the solar system's incredible past, a survivor of billions of years of cosmic history, a world that witnessed the birth of planets, the rise of life on Earth, and the transformation of the sun itself. Saturn will continue orbiting the remains of our star for countless ages, until, perhaps trillions of years in the future, Even the solar system itself begins to fade into the darkness of the expanding universe. Yet for now, Saturn remains one of the most extraordinary worlds we know. A giant planet wrapped in rings, a system of moons filled with hidden oceans and alien landscapes. A world where storms rage for months, lightning flashes through towering clouds, and invisible magnetic forces shape the surrounding space. Saturn reminds us how vast and mysterious our cosmic neighborhood truly is, and how much more there is still waiting to be discovered. Because every mission, every telescope, and every new observation continues revealing something unexpected about this distant giant. New storms, new moons, new mysteries, and perhaps someday, new answers about how planets form, how solar systems evolve, and whether life might exist beyond Earth. Until then, Saturn remains one of the greatest wonders of the solar system.
A world that continues to inspire curiosity, awe, and a sense of cosmic mystery every time we turn our eyes toward the night sky. And here at Stellar Depth, our journey through the universe is only just beginning. A giant that still holds secrets, even after centuries of observation, after powerful telescopes, after spacecraft that traveled billions of kilometers. Saturn is still not fully understood. In fact, the more scientists study this distant giant, the more mysteries appear. Every new mission, every new image, every new measurement reveals something unexpected about the planet and the strange system that surrounds it.
Saturn may look calm from Earth, a pale golden light slowly drifting across the night sky. But in reality, it is one of the most complex worlds in the solar system, and we have only begun to explore it. The Cassini mission, which arrived at Saturn in 2004, revolutionized our understanding of the planet. Over the course of 13 years, the spacecraft performed hundreds of orbits around Saturn, flying past moons, diving through the rings, and observing storms raging across the atmosphere. Cassini revealed details no one had ever seen before. Gigantic lightning storms deep inside Saturn's clouds, the enormous hexagon storm at the North Pole, hidden oceans beneath icy moons, active geysers erupting from the surface of Enceladus, and strange seasonal changes in Saturn's atmosphere as the planet slowly moved around the sun. But perhaps the most important lesson Cassini taught scientists was this: Saturn is not a finished story. It is a dynamic system that continues changing even today. Storms form and fade, rings shift and evolve. Moons interact with the planet in ways we are still trying to understand. Take Saturn's atmosphere, for example. Despite decades of research, scientists still cannot fully explain the planet's extreme wind speeds. Saturn rotates incredibly fast, completing a full rotation in just about 10 hours. And this rapid spin creates powerful jet streams across the atmosphere. But the exact mechanism that maintains those high speeds remain uncertain. Why are Saturn's winds so much faster than those on Earth? Why do some storms appear suddenly and grow to enormous sizes? And why does the mysterious hexagon storm at the North Pole maintain its perfect geometric shape? These questions remain unsolved. Saturn's interior is equally mysterious. Scientists believe the planet contains vast oceans of liquid metallic hydrogen, but the exact structure of the deep interior remains unknown. Data from Cassini suggests Saturn's core may be far larger and more diffuse than previously believed. Instead of a compact rocky center, Saturn may contain a fuzzy core. a region where heavy elements gradually blend into surrounding hydrogen layers. This idea challenges older theories about how giant planets form. If Saturn's core truly extends across a huge region of the planet's interior, it may change our understanding of how gas giants develop throughout the universe. But perhaps the most exciting discoveries around Saturn involve its moons. Among the dozens of satellites orbiting the planet, several worlds have captured the attention of scientists searching for life beyond Earth. One of these is Enceladus. This small icy moon, only about 500 kilometers wide, contains a hidden ocean beneath its frozen crust. Cassini discovered enormous geysers erupting from cracks near the moon's south pole, spraying water vapor, ice particles, and organic molecules into space. These plumes originate from a warm ocean beneath the surface. Even more astonishing, the ocean appears to contain many of the ingredients necessary for life: water, organic compounds, chemical energy, and possibly hydrothermal activity on the ocean floor. On Earth, environments like this are often home to thriving ecosystems of microorganisms. If similar processes occur on Enceladus, life might exist within its hidden ocean. Another fascinating world is Titan, Saturn's largest moon. Titan is larger than the planet Mercury and possesses a thick atmosphere rich in nitrogen and methane. Its surface contains lakes and rivers, but not of water. Instead, Titan's lakes are filled with liquid methane and ethane. In many ways, Titan resembles a strange mirror of Earth. It has clouds, rain, rivers, shorelines.
But everything operates at extremely low temperatures, around minus 180 degrees Celsius. Some scientists believe Titan could host exotic forms of chemistry, perhaps even forms of life very different from anything we know. Future missions may one day explore Titan's surface directly. NASA is already planning a remarkable spacecraft called Dragonfly, a flying drone designed to explore Titan's landscapes by hopping between different locations across the moon. Dragonfly could help scientists study Titan's atmosphere, chemistry, and surface features in unprecedented detail. And Enceladus may also be explored again. Some researchers have proposed sending a spacecraft designed specifically to fly through the moon's water plumes and analyze their contents.
Such a mission could potentially detect signs of microbial life. If life were discovered on one of Saturn's moons, it would transform our understanding of biology in the universe. It would show that life is not unique to Earth, that biology may emerge wherever the right conditions exist, and Saturn's system could become one of the most important places in the search for life beyond our planet. But even without life, Saturn continues to amaze scientists. Its rings remain one of the most beautiful structures in the solar system, yet they are also fragile and temporary. Over time, the rings are slowly being pulled into the planet's atmosphere. This means the rings we see today may not last forever. Some scientists believe Saturn's rings may disappear within 100 million years. In cosmic terms, that is a very short time, which means we may be living during a special moment in the history of the solar system. A time when Saturn's rings are at their brightest and most spectacular. Millions of years in the future, Saturn may look very different. Without its rings, it would appear as a simple gas giant drifting through space. But for now, the rings remain one of the most recognizable and breathtaking sights in astronomy. A glowing halo of ice surrounding a giant world. seen through even small telescopes from Earth, and yet Saturn still holds countless secrets. New telescopes like the James Webb Space Telescope are already providing fresh insights into the planet's atmosphere and rings. Future missions may one day return to Saturn to explore its moons, its magnetosphere, and perhaps even deploy probes into its atmosphere. Each new discovery will reveal more about how this incredible system works, and perhaps answer some of the questions that still puzzle scientists today. Why does Saturn's hexagon storm exist? How exactly did the rings form? What lies deep within the planet's mysterious interior? And could life exist in the hidden oceans of its moons? Saturn reminds us that the solar system is far more complex than we once imagined. Each planet, each moon, each ring particle, all part of a vast cosmic story that continues unfolding. And even now, billions of kilometers away, Saturn continues spinning silently through the darkness. Storms moving across its clouds, rings glittering in the sunlight, moons circling endlessly around the giant planet. A distant world that still has many secrets left to reveal. And here at Stellar Depth, we will continue exploring those mysteries, traveling deeper into the universe one story at a time. The legacy of Saturn. When humans first looked toward the sky thousands of years ago, Saturn was already there, a faint golden point of light moving slowly among the stars. Ancient civilizations noticed this strange wandering object long before telescopes existed. The Babylonians tracked its movement across the heavens. The Greeks named it after Cronus, the father of Zeus. Later, the Romans gave it the name Saturn, the god of time and agriculture. To early astronomers, Saturn represented something mysterious and distant. It moved slower than any other visible planet, taking nearly 30 years to complete one orbit around the sun. Because of this slow motion, many ancient cultures associated Saturn with time, cycles, and long cosmic rhythms. Yet no one could imagine what Saturn truly was. It was not until 1610, when Galileo Galilei pointed one of their first telescopes toward the sky, that humanity saw Saturn in a completely new way. But even then, the discovery was confusing. Through Galileo's small telescope, Saturn did not appear as a normal planet. Instead, it looked like a strange object with two large handles on each side. Galileo described it as a planet with ears. He could not understand what he was seeing. The rings of Saturn were too thin and delicate for his telescope to resolve clearly. For years, astronomers debated the true shape of Saturn until better telescopes eventually revealed the truth. The planet was surrounded by rings, a structure unlike anything known in the solar system. This discovery changed astronomy forever. For centuries afterward, Saturn remained one of the most fascinating objects visible through telescopes. Observers studied its rings, its strange banded atmosphere, and its growing collection of moons. But Saturn was still incredibly far away. Even the most powerful telescopes could only reveal limited details. The real exploration of Saturn began in the space age. During the late 20th century, humanity finally began sending spacecraft into the outer solar system. The first visitor to Saturn was Pioneer 11, which flew past the planet in 1979. The spacecraft captured the first close-up images of Saturn's clouds and rings, revealing details never seen before. Soon after came Voyager 1 in 1980 and Voyager 2 in 1981. These missions transformed Saturn from a distant mystery into a real world. The Voyager spacecraft discovered new moons. They photographed intricate structures within the rings. They revealed the complexity of Saturn's atmosphere. And they provided the first detailed images of Titan, Saturn's largest moon. But the greatest exploration of Saturn came decades later with the Cassini-Huygens mission.
Launched in 1997, Cassini traveled nearly 7 years through space before finally arriving at Saturn in 2004. For the next 13 years, Cassini studied the Saturn system in extraordinary detail. It orbited the planet hundreds of times. It flew through the rings, it performed close encounters with many of Saturn's moons, and it carried a small probe called Huygens, which descended through the atmosphere of Titan in 2005. The Huygens probe became the first spacecraft ever to land on a moon in the outer solar system. As it descended through Titan's thick orange atmosphere, its cameras revealed landscapes unlike anything scientists had expected. Rivers, channels carved into the surface, rounded stones shaped by flowing liquid.
But instead of water, Titan's rivers contained liquid methane. The probe eventually landed on Titan's frozen surface, transmitting images and data before its mission ended. Meanwhile, Cassini continued exploring the Saturn system. One of its most important discoveries came from the small moon Enceladus. Cassini observed enormous plumes of water vapor erupting from cracks near the moon's south pole. These geysers were shooting material hundreds of kilometers into space. Further analysis revealed that the plumes contained water, organic molecules, and tiny grains of salt. All evidence pointed towards something extraordinary: a global ocean beneath Enceladus's icy crust. This discovery instantly made Enceladus one of the most intriguing places in the solar system. Scientists realized that this hidden ocean could potentially contain conditions suitable for life. Cassini also revealed countless details about Saturn itself. The spacecraft captured spectacular images of the rings. It studied massive storms sweeping across the atmosphere. It observed the giant hexagon storm at the North Pole. And it measured Saturn's gravitational field, helping scientists understand the planet's internal structure. But perhaps the most dramatic moment of the Cassini mission came at its very end. By 2017, the spacecraft was running low on fuel. Without fuel, Cassini would no longer be able to control its orbit. Eventually, it could crash into one of Saturn's moons. Scientists wanted to avoid contaminating moons like Enceladus or Titan with microbes from Earth. So they made a bold decision. Cassini would dive into Saturn's atmosphere. During the final phase of its mission, Cassini performed a series of daring orbits that carried it between Saturn and its rings, a region never explored before. These close passes allowed scientists to collect valuable data about the planet's gravity, magnetic field, and ring structure. Finally, on September 15, 2017, Cassini entered Saturn's atmosphere. As the spacecraft plunged deeper into the clouds, friction began tearing it apart. Its antennas continued transmitting data until the final moment. Then the signal ended. Cassini had become part of Saturn, the spacecraft that spent 13 years exploring the giant planet had completed its journey. But its discoveries continue shaping our understanding of the solar system today. Cassini revealed that Saturn is not just a planet. It is an entire system of interacting worlds, a place where moons may contain hidden oceans, where rings form and disappear, where storms larger than Earth rage through alien skies, and where the laws of physics create environments far beyond anything we experience on our planet. Yet Saturn's story is far from finished. Future missions will almost certainly return. Scientists are already planning spacecraft to explore Titan's surface, investigate Enceladus's ocean, and continue studying Saturn's atmosphere and rings. Each new mission will reveal more about this extraordinary world, because Saturn still holds many secrets, and every answer leads to new questions. What lies deep within Saturn's mysterious interior? How exactly did its rings form? Could life exist in the oceans of its moons? The search for these answers continues, but one thing is certain. Saturn will always remain one of the most remarkable worlds in this solar system. A planet of rings, a system of strange moons, a giant world where storms rage beneath golden clouds, and a reminder that the universe is far more mysterious and far more beautiful than we once imagined. And here at Stellar Depth, our journey through the cosmos continues, because beyond Saturn, beyond our solar system, countless other worlds are waiting to be discovered. Saturn and the endless mystery of the universe. For centuries, Saturn has stood as one of the most captivating objects in the night sky. Even with the naked eye, it appears different from the stars around it. Unlike distant suns that twinkle in the darkness, Saturn shines with a steady golden light. It moves slowly across the sky over months and years, tracing a path that ancient astronomers carefully observed long before the modern age of science. But what once appeared as a mysterious wandering star is now known to be one of the most extraordinary worlds in our solar system. A giant planet, a system of rings, a family of moons, a place where physics unfolds on scales far beyond anything we experience on Earth. And yet, even after decades of exploration, Saturn continues to challenge our understanding of the universe. One reason Saturn fascinates scientists so deeply is that it represents a class of worlds known as gas giants. These planets are very different from rocky planets like Earth, Mars, or Venus. Instead of having solid surfaces, gas giants are composed mostly of hydrogen and helium, the same elements that make up stars. Saturn, however, is unique even among gas giants. Although Jupiter is larger, Saturn is the least dense planet in the solar system. In fact, if you could somehow place Saturn in an enormous ocean, it would float. Of course, such an ocean could never exist, because Saturn is far larger than any planet capable of containing it. But the comparison illustrates just how light Saturn's overall density truly is. Despite this low density, Saturn still possesses enormous gravity. Its mass is more than 95 times that of Earth, meaning its gravitational pull dominates an enormous region of space. Dozens of moons orbit the planet, and countless particles form the spectacular ring system that surrounds it. But Saturn is more than just a massive world. It is also a natural laboratory for understanding how planets form and evolve. When astronomers observe planets around distant stars, worlds known as exoplanets, many of them resemble Saturn in size and composition. Studying Saturn helps scientists understand how these distant planets may behave, what their atmospheres might look like, and how giant planets influence the architecture of entire planetary systems. In other words, Saturn is not just important for understanding our solar system. It helps us understand planets throughout the galaxy. Yet Saturn still holds mysteries that scientists have not fully solved. One of these mysteries involves the planet's rotation. You might think measuring how fast Saturn spins would be simple, but Saturn's thick atmosphere makes this surprisingly difficult. Unlike rocky planets, Saturn does not have a visible surface that can be tracked easily. Different layers of the atmosphere move at different speeds. Storms drift across the clouds. Jet streams flow around the planet. All of this makes it challenging to determine the exact rotation rate of Saturn's deep interior. Even after decades of study, scientists still debate the precise length of a Saturn day. Another mystery involves the planet's magnetic field. Most planets with magnetic fields, as including Earth and Jupiter, have magnetic poles that are slightly tilted relative to their rotation axis. But Saturn's magnetic field appears almost perfectly aligned with its rotation. This near perfect alignment is unusual and difficult to explain with existing models of planetary magnetism. Understanding Saturn's magnetic field could provide important clues about how magnetic dynamos operate inside giant planets. Saturn's rings also continue to raise questions. Although scientists now believe the rings may be relatively young, their exact origin remains uncertain. Were they formed from the destruction of a moon? Did they arise from leftover material during the early solar system? Or did some other process create them? Future observations may finally reveal the answer, but perhaps the most exciting discoveries still waiting at Saturn involve its moons. Saturn's moon, Enceladus, has already become one of the most promising locations in the search for life beyond Earth. The discovery of its underground ocean, along with evidence of hydrothermal activity beneath the seafloor, suggests that the moon may contain environments similar to those where life thrives in Earth's oceans. Meanwhile, Titan continues to fascinate scientists with its complex chemistry. Titan's atmosphere contains large amounts of organic molecules, the building blocks of life. Over time, these molecules may form even more complex structures through chemical reactions in the moon's atmosphere and on its surface. Although Titan's lakes are made of methane rather than water, some scientists speculate that entirely different forms of life could theoretically exist in such environments. Whether or not life exists on Titan or Enceladus remains unknown. But the possibility alone makes Saturn's system one of the most important targets for future exploration. And exploration is far from finished. New missions are already being planned. One of the most ambitious is NASA's Dragonfly mission, scheduled to launch in the coming years. Dragonfly will travel to Titan and deploy a robotic drone capable of flying through the moon's thick atmosphere. Because Titan's gravity is low and its air is dense, flying there is surprisingly easy. Dragonfly will hop between locations across Titan's surface, studying the moon's chemistry, geology, and atmospheric processes. The mission may reveal how organic molecules evolve in Titan's unique environment. It could also provide insight into how the chemical ingredients for life develop on planetary bodies. Future missions may also return to Enceladus. Some scientists have proposed sending spacecraft capable of flying directly through the moon's plumes and analyzing the water particles in detail. Others have imagined probes that could eventually land near the South Polar geysers. Such missions might detect complex organic molecules, or even signs of microbial life. If life were discovered in Saturn's system, it would be one of the most profound discoveries in human history. It would mean that life can arise in environments far different from Earth, and it would suggest that the universe may be filled with living worlds waiting to be explored. Even without life, Saturn's system continues to amaze scientists and astronomers alike. Its storms, rings, moons, and magnetic environment form one of the most complex planetary systems in our cosmic neighborhood. Every observation reveals new layers of complexity. Every mission uncovers new mysteries, and every discovery reminds us how much there is still left to learn. Perhaps that is the most powerful lesson Saturn offers. Even after centuries of study, even after spacecraft have traveled billions of kilometers to explore it, Saturn remains mysterious. It reminds us that the universe is not a simple place. It is vast, dynamic, full of strange worlds and unexpected discoveries. And Saturn, with its shining rings and hidden oceans, stands as one of the greatest symbols of that cosmic wonder. A giant planet quietly orbiting the sun, a system of moons where alien oceans may hide beneath icy crusts, a world where storms rage beneath golden clouds and rings glitter in the sunlight, and a reminder that beyond the familiar skies of Earth lies a universe far more extraordinary than we ever imagined. Here at Stellar Depth, we continued that journey, exploring the most fascinating places in the cosmos and uncovering the mysteries that still wait among the stars.